Hi everyone, I'm Baihan from Columbia University. Today I'm going to share with you our work, Psychotherapy AI Companion with Reinforcement Learning Recommendations and Interpretable Policy Dynamics. This is a joint work with Guillermo, Cecchi and Djallel Bouneffouf from IBM. Here comes the methodology. Shown here is our analytical framework. You see, the input to our system is the continuous audio stream. We do not know who is speaking at which moment, and we utilize an online speaker diarization method to cut them into segments. And then, combining with the automatic speech recognition, we can separate it into transcript belong to different users. When we have those user transcripts at real time, we can compare them with the inventory items of interest, which helps us quantify the quality of the conversation. That gave us the quality of alignment in different scoring scales. Shown here are some examples of the inventory items. In this case, we are using the working alliance inventory. You can see those are statements. And then, according to different statements, there are also a key table which gave us its polarity. So for instance, in the task scale, question 2 is a plus, meaning that it is positively correlated with the task. If it is minus, it will mean it is anti-correlated. We can use this as a weighting matrix when we are computing our score in the 3 different scales. Here is an algorithm. Basically, you can potentially have inventories that corresponds to different users. Maybe there is an inventory for the therapist and an inventory for the client, and they're different. For instance, or in a TV interview, the interviewer and interviewee, they have their different criteria or rubrics to evaluate their quality. And then we can basically use a shared sentence or document embedding to embed those transcripts at the turn level and the document or the working inventory items in the embedding space, then compute their cosine similarity. This can be visualized here in this flowchart, where after the diarization, for each user, we have the transcript, and the transcript is feeding to the deep embedding. In this analysis, we use the sentence BERT as our embedding. And then the conversational quality would be measured as the pairwise cosine similarity of the current transcript versus the inventory items. Say we have 36 inventory items, it will be a vector of 36 dimensions. And then we can weight them by our alignment scale and to compute the individual scores in different scales. So there are 3 main components in our system. First, the speech processing unit utilizes diarization techniques to separate continuous audio input into dyads of the patient and therapist segment, and then transcribe it into natural languages. Natural language processing unit then tries to annotate some clinically relevant scores or ratings. Having those scores and ratings, we can collate a historical data for the recommendation system to train on. And the recommendation system, after being trained, can receive real-time input of linguistic features and output recommended topics as if we're recommending a movie or things like that. There is a variety among not only the disorders that we train the dataset upon, but also the model architectures as well as the therapeutic reward signals that we are training our reinforcement learning agents upon. For instance, if you treat the working alliance score in the task scale as your goal, you might be doing pretty well for anxiety patient, but maybe not so much for other ones. And also, if you treat the working alliance scores in the bond scale as your emphasis, it will be working good for one disorders versus the others. So our framework has the flexibility to accommodate for different therapeutic emphasis by the doctors. And then we could visualize this policy, this learn policy from different agents trained for different therapeutic purposes on different clinical conditions. And by visualizing their policy trajectories and all those kind, we could be telling some interpretable insights and actionable steps for junior therapists to learn from. So how do we formulate this into a reinforcement learning framework? As we can see from this figure, that it is more complicated than traditional reinforcement learning setting, where the agent simply interact with the world and by taking action, and the world will assign some reward and state for it to update. Since now our environment consists of a dialogue interaction between the therapist and patient. Only the therapist receives recommended action, and he or she has the option to choose to either take the advice or not take it. And after that, based on the interaction between the therapist and patient, we have a joint feedback as the reward to feedback to the recommendation agent. And as a result, the state also changed in the... So to evaluate our recommendation system, we compare 3 popular reinforcement learning methods. The first one is DDPG, the second one is TD3, and the third one is an offline reinforcement learning method called BCQ. And as we can see from their loss function, they all learn in a very stable fashion over 100 epochs. And also shown here is the turn-level test accuracy of the predicted topics. Basically, we separate the data set into a test set and also a training set. And we train the reinforcement learning agent on the training set, and then we roll it out in the test set to see how well it can predict the actual topics given by the therapist. Of course, this is no ground truth because because we're making an assumption that the data set tells us what is good versus what is not, since the therapist is supposed to be trained therapist with a lot of experience. As we can see from the results, there is a variety among not only the disorders that we train the data set upon, but also the model architectures as well as the therapeutic reward signals that we are training our reinforcement learning agents upon. For instance, if you treat the working alliance score in the task scale as your goal, you might be doing pretty well for anxiety patient, but maybe not so much for other ones. And also, if you treat the working alliance scores in the bond scale as your emphasis, it will be working good for one disorders versus the others. And then we could visualize this policy, this learn policy from different agents trained for different therapeutic purposes on different clinical conditions. And by visualizing their policy, trajectories, and all those kind, we could be telling some interpretable insights and actionable steps for junior therapists to learn from, right? So for instance, shown here is the normalized and average and standardized basically trajectory over each session, which is averaged. And that is kind of like how if you have no assumption what starting point you are, but you only know that you are a patient of anxiety or depression and all those kind, and trained with different reward signal, you can see basically the trajectory goes in different directions, meaning that if you have a trade-off over here sometimes. For instance, in anxiety patients, the bond scale seems to be doing pretty similar to the therapist data, which is the black curve, right? So which means that the therapist in the anxiety patient might be focusing more on the bond scale instead of the other dimensions. So it could also go other ways around as shown in this type of analytics. And you could also see the transition matrix, basically say the one-step transition from the last action, which is the last topic that is being discussed, jumping towards the next action. And you can also see that this type of different patients and different type of therapeutic signals will yield different outcomes. So this is an indication of how this type of visualization can pinpoint us to some potentially actionable insights that the doctors can have. Okay, and shown here is our demonstration system. We started off with some introduction and instruction about how to play with our system. Then in the quality inventory part, the users get to input their own inventory items. The working alliance inventory is put here as a default. And then on the right, we see there are different rewards, different scoring scales where the users can also change. After that, they finalize it by clicking Analyze Inventory. Then we move on to our dialogue system where the speaker diarization system is being trained. The users usually has to interact with the system for 50 to 100 times to get to relatively stable behavior because it doesn't have any historical data at all. But you can see that the MFCC features are being visualized on the left, and on the right is the weight. Finally, you can see in the quality annotation part, on the left, the current sentences is being transcribed, and you can see it on the left. And also, simultaneously, the alliance score in the straight scale are being computed and visualizes on the right in the bar chart. You can see that when we are seeing different things, it can vary up and down, and that's quite interesting. So our last part consists of our recommendations. You can see it's right below our annotations. We have a suggested next topics for our therapist to take. And our therapist, which by default is the first user, have the option to either take the suggestion and talk about the topics or not take it. So basically, that offers additional feedback to the reinforcement learning model. Thank you. If you have any questions, feel free to contact me at baihanling@columbia.edu.